Throughout this class, we'll use an approach called dimensional analysis as an aid in problem solving. In dimensional analysis, we carry units through all calculations. Units are multiplied, divided into each other, or canceled. Using dimensional analysis helps ensure that the solutions to problems yield the proper units. Moreover, it provides a systematic way of solving many numerical problems and of checking our solutions for possible errors. The key to using dimensional analysis is the use of something called a conversion factor. A conversion factor is a fraction whose numerator and denominator are the same quantity expressed in different units. A conversion factor is nothing more than a fraction. For example, we know that there are 2.54 centimeters in 1 inch. Or I could write this as a fraction, saying that there is 2.54 centimeters in 1 inch, or in 1 inch there are 2.54 centimeters. Both of these fractions are, as a matter of fact, equal to 1 because the number 2.54 centimeters is equal to 1 inch. And when you divide these two, they divide out to equal 1. These conversion factors or fractions are real handy in being able, or real handy to use in calculations to determine how many inches there are in centimeters or centimeters there are in inches, or relating to other units than inches and centimeters. Just using this as an example, let's pretend we wanted to know how many centimeters there were in 8.5 inches. To do this, we could use the conversion factor up here on the right-hand side. And we can take our 8.5 inches, put a multiply sign and a line, take the units that we are given, inches, put them down below in this fraction and put the 1 with it, and take the units that we're wanting to know and put those on the top, centimeters, and put our number 2.54 on the top, because there are 2.54 centimeters in 1 inch. Now, if you remember in math class, when I multiply something, I could technically continue this divided by sign all the way across. And in dimensional analysis, what we want to do is make sure that our units on the top and our units on the bottom cancel or cross off with each other. Notice now the units that I'm left with at the end are centimeters. When you do a dimensional analysis conversion problem, the first thing you should write down for your answer are your units. Cancel your units first, and then write down the new units as the answer. Then you can do the rest either with a calculator or by multiplying together in your head. Turns out that the answer is 21.6 centimeters. Notice that I took the desired unit and put it on the top. Desired unit and put it on the top. I wanted to know, for example here, how many centimeters there were in an inch, and I put my given units in a position where they were going to cancel or on the bottom of this fraction. Dimensional analysis always uses this technique of multiplying by a fraction so you can have the units cancel. You can have the units cancel and get the new units that you're desiring or wanting to know. Let's do a second example problem. Let's pretend that we have 115 pounds. Let's say someone weighs 115 pounds and we want to know how much is that weight in grams. Well, we might not know how many pounds there are in grams, how many grams there are in a pound or pounds there are in a gram, either way. But what's really helpful is if you look on the back cover of your textbook and open that up, there's a big table of useful conversion factors and relationships. And if we zoom in on this and look underneath mass, you can see that in 1 pound there are 453.59 grams. grams. From this, we can construct a conversion factor that will allow us to convert from pounds to grams. So we're given that we have 115 pounds. So rewrite the 115 pounds first. 115 pounds. Put a multiply sign and put a line. Always put your units in. In the conversion factor, always put your units in first and then fill in the numerical value. We want to convert from pounds to grams. Put your desired unit on the top, which is grams, so I'll put a G up here, or I'll just write out the word grams, and put the units that you have, pounds, in a position where it will cancel with the units that you already have. And if you like to draw this divided by sign all the way along and even put this number over 1, you sure can, because remember, any number over 1 is still just that number. If it helps you to remember that, hey, this is a fraction just like this is going to be a fraction, go ahead and do that. Now we use our conversion factor that we looked up in the back of the book. And in the back of the book, it told us that there were 453.6 grams. So put 453.6 grams in there in 1 pound. So put the 1 next to the pound. Notice the order that I did this in. This is very, very important for the rest of the class. First, I put my units in. First, I put my units in, the ones that I desired and the ones that I had. Then I filled in the numbers. Put the units in first, because then you'll always know you did it right. Next, go through and cancel. I know that my pounds will on the top will cancel with my pounds on the bottom, and for sure I'll end up with my units of grams at the end. Go ahead and put your units in at the end, grams, and then take your calculator and multiply the two numbers together. And if you do this, you end up with 5.22 times 10 to the 4th grams. Perhaps this is a good time to review a little bit about scientific notation. Scientific notation is nothing more than taking a number that's really big or really small and expressing it as times 10 to some power. This power right here simply means that the decimal point is either moved to the right to make it larger or to the left to make it smaller by that number. So this number could also be written as 522, and we'd move the decimal point 1, 2, 3, 4 places, because this is to the 4th power. And so we'd have to put placeholding zeros right here, and this would be the same as 52,200 grams. Many times it's easier to write really large or really small numbers in scientific notation. Conversely, let's say we had a really small number, like, for example, let's say we had a number like 2.2 times 10 to the negative 5th. The negative in the exponent here does not mean that the number is negative. It simply means that you need to move your decimal point to make it a number that's smaller than 1. In this case, we move the decimal point 5 places to the left. 1, 2, 3, 4, 5. We put the decimal point right here. You can put a 0 in front of the decimal point, like I want you to do all the time, and then you fill in placeholding zeros right here. So 0.000022 is the same as 2.2 times 10 to the negative 5th. We use scientific notation very often in this class, so get used to using that and go back and do a little review if you need to. Next thing we're going to take a look at is using 2 or more conversion factors to do a conversion. Here's an example problem. The average speed of a nitrogen molecule at 25 degrees Celsius is 515 meters per second. Convert this speed to miles per hour. Convert this speed to miles per hour. Well, notice we're changing 2 things in this. Meters to to miles and seconds to hours. So we're going to have to do 2 conversions here to make this work. We also might not know the relationship between meters and miles. For you track experts out there that are watching this, what is the mile run distance in meters? And people usually call it the 1,600 meter run, which is pretty close to a mile. An actual mile, though, is a little bit longer than that. It's 1,609 meters. So we know that there are 1,609 meters in 1 mile. You can look in the back of your textbook and find relationships like this as well. And you might not know how many seconds there are in an hour, but we do know that there are 60 seconds in 1 minute. And we also know that there are 60 minutes in 1 hour. And so we'll be able to use these 2 conversion factors as well. Notice I wrote them with equal signs right now. And then when I do the conversion factor, I'll put them as fractions. So once I know my relationships, then rewrite the number that I'm given, 515 meters per second. Put a multiply sign and put a line. And now you need to decide, what are you going to convert first? The meters to the miles or the seconds to the hours? In this case, I'm going to convert meters to miles first. You don't have to, but you can. Remember, you want to put your desired unit on the top and the units that you have in a position where it's going to cancel. The units that I have right now are meters. The units that I want to go to are miles. So I will put mile on the top, meter on the bottom. Notice I put my units in first before I put in any numbers. I put my units in first before I put in any numbers. I know that there are 1,609 meters in 1 mile. So now I put my numbers in after I put my units in. If I stopped here right now and hit equals, notice my meters would cancel with each other and I would have miles per second. Miles over seconds. Remember, you could just continue this line right here and actually put a 1 down below it, because any number written over 1 is that number. But I want to know miles per hour. So I'll put a second conversion factor in here. And eventually I want to get to hours, but I don't maybe know how many seconds there are in an hour. And so I'm going to use this conversion factor right here and put seconds, the units that I have, in a position where it's going to cancel, and put minutes as my new set of units. Notice where the seconds are in this fraction. I want to put seconds in a position where it's going to cancel right here. So where would I put seconds? Since it's on the bottom of the fraction here, I'll put seconds on the top, and then I will take my minutes and I'll put it on the bottom. Notice now I put the seconds, the thing that I want to cancel on the top, so it will cancel with the one on the bottom. Notice I put my units in first before I put any numbers in. I know that there are 60 seconds in 1 minute. And notice my seconds will end up canceling with my seconds, and if I stopped here, I'd have miles over minutes, or miles per minute. Notice that the units are equally, if not more important than the numbers I put in. Always put your units in first so you know they're canceling. Lastly, I'm going to go to miles per hour, and so I'm going to relate minutes to hours that I have in here. Let's put the minutes in a position where it's going to cancel on this fraction. Where would I want to put minutes, since it's on the bottom of this fraction, so it would cancel? I'd put it on the top, so the minutes would cancel with the minutes, and then I'll take my hours and I'll put that in a position where it's going to cancel, so I'll put it on the bottom. And I know that there are 60 minutes in an hour, so now that I have my units in here, now I can add the numbers. I could have done this portion directly in one step as well if I knew that there were 60 times 60 or 3,600 seconds in an hour, put seconds on the top and hours on the bottom. But it's equally just as good to go ahead and use more than one conversion factor as well to do the same thing. Notice my minutes will cancel with my minutes, and before I write any answer in, or before I do any calculations on my calculator, make sure you have the correct units remaining. Miles remain and hours remain, and miles per hour is what I wanted to have for my final units. Now on your calculator you can take 515 times 1 times 60 times 60 divided by 1609, or whatever order of operations, as long as you keep them straight, you want to go through. And if you do this, you end up with approximately 1.15 times 10 to the third miles per hour. Or if we didn't write this in scientific notation, remember we'd move the decimal point 1, 2, 3 places to the right, and so it would be approximately 1150 miles per hour. Fairly speedy for something as tiny as a nitrogen atom, or a nitrogen molecule, I'm sorry. Our next example problem takes a look at units that are derived, like for instance volume. It says that the Earth's oceans contain approximately 1.36 times 10 to the 9th cubic kilometers of water. Calculate this volume in liters. Well, it wants us to go from cubic kilometers to liters. Now, if you remember in our last video cast, we learned that a liter was the same as a cubic decimeter. The same as a cubic decimeter. So really what our goal to do is to convert from kilometers to the third power to decimeters to the third power. And if you look back and remember from your notes, the prefixes here, giga, mega, kilo, deci, centi, milli, micro, tell us how much larger or how much smaller a unit is than a base unit. In this case, we're given the prefix kilo, which is 10 to the third the size of a base unit, and we want to get to deci, which is 10 to the negative first of a base unit. So we can write those relationships down, and then we could use two conversion factors to go ahead and relate them. I know that in a kilometer, there are a certain number of meters. There would be 1,000, or 10 to the third meters. If I forgot that, I can look right back here at my conversion, or my prefixes. 10 to the third means that's how many base units there are in a kilo. In this case, our base unit is meter. I also know that in 1 meter there are 10, or 1 times 10 to the first, decimeters. And if I forgot that, I can look right here on my unit conversion factor and I can see that the decimeter is 1/10 the size of a base unit. In this case, the base unit is the meter. So become familiar with these units and know how much larger, how much smaller they are than a base unit, and then you can use these scientific notations right here to go ahead and help you do some prefixes. Now the problem with this is that we have cubic kilometers up here, and these are just regular kilometers and regular meters and regular decimeters. And so if I want to convert these, I'm going to end up cubing each one of these. But let's write out the units first, or let's write out the dimensional analysis first, and then we'll do that. Take the number that you're given, 1.36 times 10 to the 9th kilometers cubed. Put a multiply sign, put a line, put the units that you want to be in a position that they're going to cancel. Put the units that you have, in a position where it's going to cancel. So since I have kilometers here, I'll put kilometers down here. Put my desired units on the top, and I'm going to go to meters first. And then from there I'll go to decimeters. So I'll put meters on the top right here. Notice right now my kilometers cubed and my kilometers won't cancel. Not yet, but hold on just a second. So my relationship between meters and kilometers I can find right here. I know that there are 10 to the third, or 1,000 meters in 1 kilometer. And now comes the trickier, the unusual part. Notice that this is cubic kilometers, and this also needs to be cubic kilometers or cubic meters. And so what I do with this conversion factor is cube it. Now, if you forgot what to do with a cube that's outside the parentheses of an entire quantity that's multiplied together inside, what I do is I actually cube each individual item inside of this. So I could have written it as 1,000 cubed, meters cubed, 1 cubed, kilometer cubed, and that would be the same as writing the cube right out here. I'll cross this 3 off since we went and cubed each thing individually inside. Now, notice my cubic kilometers would cancel with my cubic kilometers. My last step then is to go from cubic meters now to decimeters, because I know if I have a cubic decimeter, that's the same as a liter, and that's what they want, is my volume of the oceans in liters. So, take the units that I have. Oh, I forgot to cancel these. Cubic kilometer and cubic kilometer will cancel off. Take the units that I have, meters, and put them in a position where they're going to cancel. I want to put meters down here. Notice I put my units in first, not my number. And then decimeter up here on the top. That's my desired unit or thing that I want to have. Put the 10 next to the decimeter. Put the 1 next to the meter. But now look back and see that this is a cubic meter, and so I'm going to have to take this entire quantity right here and cube it. So I'll write it again like this, and remember when you put a cubed quantity out here, or if it was a squared or something else, remember you have to put it in for each one of the factors inside of here. So it's actually 10 cube, decimeter cube, 1 cube, meter cube, and that takes care of this cubing right here. Notice my meter cube will now cancel with my meter cubed, and now I'm left with cubic decimeters as my units, because all the other units have canceled out. And remember, my goal is always to write down my units before I do the numbers. Always write down the units before I do my numbers. So now on my calculator I can take 1.36 times 10 to the 9th times 1,000 cubed times 10 cubed, and if I'm lucky and carry all my zeros along right, I'll end up with a quantity of approximately 1.36 times 10 to the 21st cubic decimeters, or remember, a cubic decimeter is the same as a liter. That's how to deal with cubic and also squared units, or ones that are have an exponent in their quantity amount. Last problem, what is the mass of 1 gallon of water? What is the mass of 1 gallon of water? The density of water is 1 gram per milliliter. Hey, this is a review problem because, well, it uses the density triangle. Remember, density is equal to mass divided by volume. Density is equal to mass divided by volume, and here it asks for the mass. Cover up the m with your finger. It equals density times volume. Mass is equal to density times volume. Write down your equation that you're going to use first, and then you have to be real careful about what numbers you're going to plug in. This is my volume right here. This is my density, but notice gallons will not match up with milliliters. If I put these numbers in, and I'll go ahead and put them in right now, 1 gram per milliliter, and I put the volume in as 1 gallon, notice gallons won't cancel with milliliters. No, it doesn't work. So before I do this, I've either got to convert gallons to milliliters or milliliters to gallons, and if you don't know the relationship, remember where to look. If you look in the back of your textbook, on the very back cover, there's going to be a relationship for volume. And if I zoom in on this, you can see right down here that they say in 1 gallon there are 3.7854 liters. 3.785 liters. So in this problem, we're given that it's grams per milliliter, so I'm going to have to convert from gallons to milliliters before I can do this. So write down the units that you have. 1 gallon put a multiply sign, put a line, put the units that you have, gallon, in a position where it's going to cancel, and let's go to liters, since they told us that in the back of the textbook. In 1 gallon, like they said in the back of the textbook, there are 3.785 liters. This would convert me to liters, but I want it in milliliters because that's what my density is given in grams per milliliter. So put another multiply sign and another line. Notice your gallons cancel with your gallons, and now put your units in first. Don't put numbers in, put units in. The units that we desire or want to have are milliliters, so put those on the top, and then take the units that we have and put them on the bottom, liters. Now if you forgot the relationship between milli, in this case liter, and the base unit liter, you can look back at your notes and you can see that there are 10 to the negative third, or it's a 1,000 times smaller prefix than the base unit, which means there's 1,000 of these small milli units right here in one of the base unit right here, which happens to be the liter. So there's 1,000 of the small unit, 1,000 millis in 1 liter. So if I multiply these critters together, I'll end up with my volume in milliliters. Once I've got my volume measured in milliliters, then I can plug it into the density equation right here, where I can say my mass is equal to my density, 1 gram per milliliter, times my volume of milliliters. Notice my milliliters will cancel with my milliliters, and I'll end up with my mass in grams. And it turns out that when I multiply these together right here, I've got approximately 3.78 times 10 to the third. 3.78, I should have put the answer right up here. 3.78 times 10 to the third milliliters in 1 gallon. And now I put that number in here, 3.78 times 10 to the third milliliters times 1, ends up that I have 3.78 times 10 to the third grams. Notice in all the problems that I did today, I put my units in first. Put my units at the end first, did the canceling, then I put the numbers in. Get used to doing that, where you put your units in first, because they're as important, if not more important, to making sure that you do each problem correctly.